Hello everyone, welcome to another class of Center for Engineering. Today we are going to discuss method of section in structural analysis 1. This is a most important topic for KTU university exams. A sure question can be predicted from this topic. Let's start our section. Before going to the problems, let us check what is really method of section means. This method is used to find the force in the members. Unlike method of joints, this is a fastest method. This method of section is superior to method of joint in the following case. Let us discuss why we prefer method of section than method of joint to find or analyze the force on the member. The method of joints fails to start or proceed due to non-availability of joint with only two unknown force even after finding reaction. The second case is when there is need for finding force in only few members of a large truss. Suppose we got a large truss, we have to find only few forces. Just we go to the method of section than method of joints because method of joints is so complicated and it is a time-consuming process. Now we are going to discuss about how can we find out the member force using the method of section or steps to find out the force in member using method of section. Let this truss is taken as an example. The first point is find out the member we want to find the force. Second, draw the section cut through the members. Third one is make sure that a maximum of 3 members can be cut through the section. Let us check the frame. For example, we want to know the forces on the member CF, ED and AD. We cut the section like this. The section can be even, straight or curved. Then we want to find sigma fx is equal to 0, that is total horizontal force is equal to 0, and sigma fy is equal to 0, that is total vertical force is equal to 0, and sigma m is equal to 0, that we can take appropriate moments is equal to 0 to find out the forces. After cutting the section, we can separate the truss into right section and left section. First we can cut into left section like this. This is the left section of this frame, and let us analyze the right section also. This is the right section of the truss. We need to take any one of the section, right section or left section, to analyze the problem. Carefully notice one thing. Make sure we considering the section has less number of force because we can easily find out the solution. The most important thing is we assume all the force is as tensile. Let us analyze the first question. Find out the forces on the member CD, CE and BE of the given truss. First, we want to find out the free body diagram. While drawing the free body diagram, we want to eliminate the hinged supports into a reactional components RA and RB. Then find out where we want to find the force. We want to find the forces on the member CD, CE and EB. So draw the section line connecting these 3 members like this. Next, we want to find the support reactions RA and RB. To find the support reaction, total upward force that is equal to total downward force. The total upward force in this truss is RA and RB. So RA plus RB that is equal to total downward force are 2000 and 4000. So RA plus RB that is equal to 2000 plus 4000 that is equal to 6000. Next, we want to find the moment about A or moment about B is equal to 0. Let I take moment about A is equal to 0. We know that moment is equal to forces into perpendicular distance. If we take moment about A equal to 0, we want to take the forces RB, 4000 and 2000 into corresponding perpendicular distances. Now we take RB, the perpendicular distance is 6 meter. Then we want to take the force 2000, the perpendicular distance is 1.5 meter. Then we want to take the force 4000, the perpendicular distance is 3 plus 1.5, that is equal to 4.5. Note that if the force is horizontal, the perpendicular distance is also vertical. Then if the force is vertical, the perpendicular distance is horizontal. So RB into 6 minus 2000 into 1.5 minus 4000 into 4.5, that is equal to 0. Therefore RB is equal to 3500 Newton and RA is equal to 2500 Newton. Step 2. Separate the section into right and left portion. The left section is this and the right section is this. We want to take only one section. Let I take the right section. This is the right section. We want to find sigma Fy is equal to 0. That is, all the vertical force equal to 0. The vertical forces in these members are RB upward direction, 4000 downward direction, and FCE sin 60, that is also downward direction. So 4000 taking downward direction is positive and upward direction is negative, minus RB is 3500 minus FCE sin 60, that is equal to 0. So FCE is equal to minus 577.25 Newton. The minus sign indicates it's a compression member. Next, we want to find sigma Fx equal to 0. Total horizontal forces equal to 0. The horizontal forces in these members are FBE, FCE cos 60 and FCD. Taking the left portion is negative and the right portion is positive, so the FB is acting to the left of the portion, so FB is negative, minus FCD cos 60 minus FCD is equal to 0. Take as equation number 1. Take sigma MC is equal to 0. That is, moment about C is equal to 0. Why we take moment about C is equal to 0? Why don't we take any other points? Because the majority of force is acting on C or come out through C. So if we take moment about C is equal to 0, the only force which causes the moment is FBE and RB. So we can find out FBE. Then we want to find the perpendicular distance from RB and FBE. If RB is a perpendicular force, so the perpendicular distance from C is horizontal. Like this. This is 1.5 meter. And if FB is a horizontal force, the perpendicular distance from C is vertical. That is 1.5 tan 60 from the triangle. This is also a 60 degree because this triangle is a equilateral triangle. RB into 1.5 minus FBE into 1.5 tan 60 is equal to 0. Taking anti-clockwise is positive and clockwise is negative, thus we get the sign conversions. FBE is equal to 2020 Newton. There is a positive sign which indicates this is a tensile force. From the equation 1, we also get FCD is equal to minus 1732.05 Newton. The minus sign indicates it is a compression member. So we find out all the member forces in the question. Let's go to the next question. Determine the forces on the member DE, EO, ML of the given structure. This is a complex truss. To find out the forces through the method of section is easier than method of joints. This problem is analyzing through method of joints is a tedious process. This example shows how we can easily find out the member force using method of section. First, we want to find out the free body diagram. The free body diagram is this. During draw the free body diagram, we want to eliminate the hinged support and introduce the support reactions RA and RB. The next step, we want to find out the support reactions RA and RA. To find out the support reaction, This structure is a symmetric structure because both the left and right portion of this structure is same. So, to find out the support reactions due to symmetry, Ra plus Ri is equal to total downward forces. The total downward forces are 40 plus 40 plus 40 plus 40 plus 40 plus 40 plus 40. That is equal to 280. Ra is equal to Rb is equal to half of the total load due to symmetric structure only. Here, AB is equal to BC is equal to CD is equal to DE, that is equal to A. The horizontal distance from A to EL is 10.5 meter. So, from B to EL, the distance is 3 by 4 times 10.5. That is this distance B to EL. Then, the distance from C to EL is 1 by 2 times the 10.5. That is equal to 5.25 meter. That is this distance. And the distance from D to EL is 1 by 4 times 10.5. That is equal to 2.625 meter. Now we can take the section, take left or right of the section. We want to find the forces on the member DE, EO and ML. So the section be drawn through connecting these members like this. We can take either left or right of the section. Here I take the left section. Taking moment about E is equal to 0. So we can find angle alpha. This diagram indicates that are the perpendicular distance with respect to force to E. 140 into 10.5. The 140 is the upward reactional component and 10.5 is the perpendicular distance to E. This positive sign indicates we take the anti-clockwise as positive and clockwise direction as negative. Minus 40 into 7.85. 40 is the downward force and it is anti-clockwise. And the perpendicular distance is 7.8 meters. So we take as minus 40 into 7.85 minus 40 into 5.25 minus 40 into 2.625 minus FML into 10.5 tan alpha. FML is this force and the perpendicular distance to E is this. We don't have angle alpha, so this distance we put it as 10.5 tan alpha. FML is equal to 841 divided by 10.5 tan alpha. We have to find angle alpha. So, take out the triangle. Alpha is equal to 10.5 tan 30 divided by 3.5. That is, tan is equal to opposite side by adjacent side. Alpha is equal to 60 degree. FML is equal to 841 divided by 10.5 tan 30 degree is equal to 138.56 kN. The positive sign indicates it's a tension member. So, we want to find sigma Fx is equal to 0. That is, total horizontal force acting on this member is equal to 0. The horizontal force acting on this section are FDE cos 30, FEO cos 60 and FML. That is, FDE cos 30 degree plus FEO cos 60 degree plus FML is equal to 0. That is 0.866 FDE plus 0.5 FEO plus 138.56 equal to 0. That is 0.86 FDE plus 0.5 FEO is equal to minus 138.56. Put it as equation number 1. Next, we want to find the total vertical force equal to 0. That is sigma Fy is equal to 0. The vertical force acting are these 340 kN and the upward vertical force 140 kN and FEO sin 60 degree and FDE sin 30 degree. That is 140 minus 40 minus 40 minus 40 plus FDE sin 30 plus FEO sin 60. The minus force indicate we take all the upward force as positive and downward force as negative. Put it as equation number 2. Solving the equation 1 and 2, we get FDE is equal to minus 239.98 kilonewton. Its minus sign indicate it is a compression member. FEO is equal to 103.8 kilonewton. With a positive sign indicate it's a tension member. We found all the member forces in the question. Next, we want to do our last problem. Find out the forces in the member U3, U4, U4L4, L4L5 of the given truss. This is our truss. This is a larger truss, but we can analyze simply by method of suction. First, we want to draw the free body diagram. This is the free body diagram. We eliminating the hinge support and introducing RA and RB support reactions. Let us examine the structure. This structure is a symmetric structure. We know that in symmetric structure, we can easily find out the reaction RA and RB. So, we are going to find out the total reactions is equal to 0. Due to symmetry, the both upward reactions are RA and RB is equal to downward reactions 80 plus 80 plus 80 plus 80 plus 80, that is equal to 400 kilonewton. Due to symmetric structure, RA is equal to RB is equal to 200 kilonewton. We know to find out the member forces in U3, U4, U4, L4 and L4, L5. So, we want to draw the section line cut through these members like this. Take the right or left section. Let us take the left of the section. Now we want to find the moment about L4 is equal to 0. Why we found moment about L4 is equal to 0? Because majority of the force is acting to L4. Thus we can easily find out the force FU3, U4. What are the force which causes moment is 200 kilonewton, 80 kilonewton, 80 kilonewton and FU3, U4. This 80 kilonewton will not affect any moment. 3, 2, 1, start. Let us take the left of the section. Now we want to take moment about L4 is equal to 0. Why we take the moment about L4 is equal to 0? Because majority of the force are coming out from L4. Thus we can easily find out the force FU3, U4. What are the force which causes moments are 200 kilonewton, 80 kilonewton, 80 kilonewton and FU3, U4. This 80 kilonewton will not cause any moment. Let us find out the perpendicular distance to L4 of each forces. First, FU3, U4. The perpendicular distance of the force FU3, U4 is x. We want to find out the value of x. X is equal to 1.5 tan 60 degree. 200 into 9 minus 80 into 6 minus 80 into 3 plus FU3, U4 into 1.5 tan 60 is equal to 0. Taking the clockwise as positive and anti-clockwise as negative. FU3, U4 is equal to minus 415.6 kilonewton. The minus sign indicate it's a compression member. Let's take sigma Fx is equal to 0. That is, total horizontal force acting on this section is equal to 0. Now identify what are the horizontal forces. The horizontal forces are FU3, U4, FL4, U4 for 60 degree, FL4, L5. That is FU3, U4 plus FL4, U5 for 60 plus FL4, L5 is equal to 0. That is 0.5 FL4, U5 plus FL4, L5 that is equal to 415.6 kilonewton. Take it as equation number 1. Let's take sigma Fy is equal to 0. That is, total vertical force is equal to 0. The vertical forces are 200 kilonewton in upward direction, the both 380 kilonewtons force and FL4 U4 sin 60 degree. that is 200 minus 80 minus 80 minus 80 plus FL4U5 sin 60 is equal to 0, taking upward direction as positive and downward direction as negative. FL4U5 is equal to 46.18. The positive sign indicates it is a tension member. From equation 1, we get FL4L5 is equal to minus 392.51 kilonewton. I hope you all understand my class. Like, share and subscribe. You can add any doubts to the comment section.